if we have two equations, a e to the 3k equals 8, a e to the 5k equals 3, as at the end of the last video clip, we can solve this by dividing the two equations. The difference here is that we before had an ab to the x and an ae to the x, or an ab to the x, well, it was ab to the x in both cases. Now it's ae to the kx, and we have to solve this way. Okay? Left-hand side, of course, gives us this. Right-hand side gives us this. When we divide, the a's divide out. E to the 5k over e to the 3k, I'm sorry, over e to the 5k, negative 2k. K is our variable. To solve this, we take the natural log of both sides. Natural log of e to the minus 2k, of course, is just negative 2k. And we can then solve for k, which is going to be negative natural log of 8/3 over 2. And that equals just some number, which we take and substitute back into one of the two original equations. And still writing k as negative natural log of 8/3 over 2. We would have this. Now, if you have something that looks like this, it looks intimidating, but this is just a number. Keep your wits about you, follow your order of operations, and use your calculator, and this just reduces to some number. And whatever that number is, we're going to divide both sides by it, and a is going to be 8 over whatever that number is. Okay? What if we have an equation of the form 2.7 to the x equals 9, an exponential equation where our variable's in the exponent? Well, as we just saw, we're going to take the log of both sides, and we're going to have the log, and this is kind of written real poorly. What we actually have here is x times the log of 2.7. And that looks a little bit strange there. But that should be x times the log of 2.7 is the log of 9, so x is the log of 9 divided by the log of 2.7. And let's emphasize that that's not the log of 9 over 2.7. Take log 9, take log 2.7, divide them, then take the log of 9 over 2.7, and you'll see that they aren't even close to being the same thing. Remember that the log of 9 over 2.7 is the log of 9 minus the log of 2.7, not the log of 9 divided by the log of 2.7. And it's also, to take the confusion one step further, it's not the log of 9 minus 2.7, because 9 is divided by 2.7. You don't suddenly get this minus here. Okay? It's neither of those, and you've got to be careful about that. You've got to know the laws of logarithms and check it out every time you use them. Okay, if we have 3 to the 2x minus 5 equals 15, how do we solve this equation? Well, same way. What we're looking for is up here in the exponents, we're going to take the log of both sides to bring that out of the exponent. We're going to get 2x minus 5 times the log of 3 equals the log of 15. And then we solve 2x minus 5 is the log of 15 over log of 3. We add 5 to both sides and then take 1/2 of both sides and we isolate x. And remember that all this is just a number that can be evaluated on your calculator. One more exponential equation, 2 to the x minus 12 to the 4x equals 0. If we took the log of both sides here, we would have the log of a difference of two numbers, and there's no law of logarithms that allows us to simplify that. So we add the 12 to the 4x to both sides, we get 2x equals 12 to the 4x, and then we take logs. We get x log 2 equals 4x log 12, and then we simplify that by bringing all our x terms onto one side, factoring out x, and dividing by the rest. However, we don't really need to divide by the rest. If we see that x times this thing is 0, this thing isn't 0. No way is that 0. You can evaluate it in your calculator and be sure, but it's not 0. Log of 12 is bigger than log 2. When you multiply it before, this term's a lot bigger, and you're subtracting it, so it's not going to be the same. Okay? This isn't 0. It ain't 0. That's got to be 0. So our conclusion is x equals 0.